On behalf of Space Education and Research Foundation, and on my personal behalf, I am very happy to welcome Professor R. Suresh and all the participants of this webinar from different countries. This is the fifth and the last talk in this series on satellite meteorology, and the today's topic is applications of satellite meteorology data in climate studies. And Professor Suresh will cover this today. And let me also make an announcement before Professor Suresh start making his presentation, that if there are any questions which we have skipped in 1, 2, and 3, 4 previous talks by Professor Suresh, please raise those queries through your chat in this session, and he will try to answer all those. And if something remains, you can also write those questions by email, and then we will reply. Of course, asking it by chat today is beneficial, because today when he replies, that reply will go to all those participating, all those listening. And if you individually write an email, then your question will come to me or either to Professor Suresh, and the answer will also only come to you. So that is a slight difference. But please do write either chat or email about the queries that you may have. And my email address is anyway there with you, and Professor Suresh's email is there in all the second slide of all his presentations. So please feel free to do it. And Professor Suresh has been with you and with me for last 5 days, and he has been an extremely good teacher to all of us, and we are learning a very great deal from him. So with these few words, I will not take much of your time. I request Professor Suresh to start his talk. Professor Suresh, please.
Thank you, Professor Words. Very good morning, good afternoon, and whatsoever is there, depending on the region of interest in which we are talking on. And this is the fifth and final module in satellite meteorology. So the slide is not advancing. Are you controlling still? Yeah, now it goes. So in this module, we are going to cover the utility of satellite data in climate studies. As a recapitulation of whatever we did earlier, we just covered the basic concepts of remote sensing, and we introduced ourselves to the satellite meteorology in brief. And in the second module, we saw how over a period of time the polar orbiting satellite and geostationary satellite evolved. In the third module, we saw the satellite data-based products and the generation of that one, and then how to interpret those products and imageries derived from the satellite data. Yesterday, the fourth module, we saw the day-to-day application of satellite data in local weather, severe weather forecast, including cyclone track and cyclone forecasting. In today's talk, we are switching over in a new dimension. This is on a long-term basis, though it will be applicable on the day-to-day basis also. But basically, the climate we mean, it's a bigger system. So how the satellite data and then how the satellite will be useful for climate monitoring and then of the climatology. In addition, how the satellite data will be in addition to validate the model, whether it is a numerical model or climate model. The use of satellite data and products in validating numerical model. I'm just approaching this slide in such a way that probably we have good understanding on how the data is useful on day-to-day weather application. So here it will be a mixture of all, how the sensors will be used, and then how the revalidation can be done, how if at all any error or query is coming in, how the satellite data from the sensors, whatever is there, it will be in a position to address the query, etc. So I am going to concentrate that way. We said, from very humble beginning of 1960s, wherein mere sensor radiometers on board, and then thereafter TOWS technology came in 1980s, and then 1990s advanced TOWS was there, and then how the signal radiometer signals, etc., evolved, and how the spectrometers, etc., is defined depending on the users, the requirement, etc. To the current one of hyperspectral observation, hyperspectral channel, etc. For the day, and the day also I showed you a weighing function of 500 channels from AIRS, atmospheric infrared sound channel. I have a full fascination for this set of what you call increased number of channels, and then thereby the vertical resolution layer base is minimized nowadays. Earlier, whatever data we were getting as an extrapolation, it was only a layer based, and then now we are almost coming to as if it was get from the song and then reduce on data. So the hyperspectral observations they improve when once it is injected into a numerical model. For this one, a numerical model for improving the performance, and then the same way probably validating the numerical model and climate model. These data are quite useful. Why it is more, that's what I explained to the TOWS and ATOWS, which are almost like a layer averageness. Say 8 millibar or 700 millibar means it is not exactly precise height, it is about 1 kilometer layer thickness over that was there because it was sound. From that we derived how top height. So increased vertical resolution, that is the main advantage. This is in regard to both temperature profile as well as the moisture profile. Both are needed for our day-to-day application as well as building the climatology. In addition, the satellite data is quite useful for deriving the surface temperature, which has an improved version from the TOWS and ATOWS, because the skin effect and the surface temperature, etc., which was in vogue in 1980s and 90s, with the increased number of channels, the skin effect concentration, contribution to the vertical temperature profile, that has been minimized. Besides this, the hyperspectral channels are useful for observing the trace gases and then greenhouse gases as such. So thereby the climatologic model and the climate change, etc., the present day, whatever we are talking about, we will be in a position to address relatively better terms in regard to scientific tools data with us. In addition to this, the hyperspectral observations give some information about the cloud amounts and then cloud top pressure, cloud top temperature, aerosol optical depth, so on and so forth. There are so many products, some of which we already covered in the limited period of our lecture in the past 4 days. And all these sensors, whether they are having their own validation or not, if at all any quality check is there, because it's already once released, it is on board, and then whether it is a degradation going on. Like yesterday, what I was saying, the cut in the operations setup, we suffered a lot because it was a flag of the carrier. It was launched for only 3 years, worked for 10 years, and then the April 2009 storm, Bijli was probably, it was giving a wrong center right from 1 degree to 5 degree latitude difference, meaning 100 kilometer to 500 kilometer difference in meaning, and then ultimately it was accepted that there was a degradation in the motor of the onboard radar and an antenna, etc. So ultimately it was decommissioned in the month of November in 2009. So this is what we call degradation, how to validate or not. In the present day with the AIS channel, etc., we have the monthly mean spectral average radiance, and then that is a solid that is getting plotted, and then the launcher is periodically analyzing whether any degradation is there. I will be giving some example, typical example of how this sort of thing is happening. So as I said, the last para, the Goldberg in NOAA, I have given the reference here also. I am giving the reference. You can see in the present day at age, Goldberg 2009, 2013, etc. UCAR materials are available. Even the NOAA website material is also available. So that's not a great deal in picking up the material what I am speaking about. So here probably the moment the spectral data is there, and then probably we have to understand what is ascending pass and descending pass, which we already introduced in the second module itself. Whenever we say ascending, it is a local time, equator crossing time is somewhere around 1:30 in the local time. Whereas the descending pass is coming from north to south, it will be crossing midnight, just midnight after that, 1.5 hours. That is our language is very early morning or wee hours. The local time is local time. Okay, so during night time the descending pass is there, during daytime the ascending pass crossing the equator, and with that only the data etc. Probably we are supposed to look at it, whether what you call country from the solar angle, all the spectral characteristics have been perfectly monitored, and the way in which probably we understand it, whenever warmer region or something like that, it is corresponding to dry and descending air. Whenever there is a cold region, it is corresponding to moist, because after all, the radiance is measured from the cloud top or rising body's top, which is nothing but ascending air means normally a moist ascending air will go on the higher height. That is one of the reasons probably once it is getting into brightness temperature, it is given as the cold color, and then this is a typical picture of the cold upper air tropospheric temperatures that have just been plotted. So the top one which I am showing is the ascending pass of January, and then January descending pass, and then July ascending pass and July descending point path. So now the spectral characteristic which I was talking about on a monthly scale, probably know whether the performance, whether any degradation is there or perfectly all right or something like that. That sort of validation is done by the launcher himself, and this is for the 8th channel I am putting about. So in regard to the validation, what they did, a simulated clear sky radiation minus the observed clear sky radiation, that is which is converted into brightness temperature always. So that has been plotted as a bias. Top portion of the view graph, you are seeing ECMWF model bias, and then the bottom one is from the NSERF bias. So you can very well see that the graph is almost similar everywhere, but for this particular area, which I circled in red color, which is varying somewhere between 1400 and 1600 wave number. So this suggests that probably the bias from, as if we know the model performance is getting debilitated in NSERF, etc. So here itself it suggests that ECMWF is model is relatively better than what we call NSERF model, etc. This is one of the what we call publication in 2009 it has been coming to, and this is a regular what we call exercise that they are doing it, and then with this they are even if at all any wrong value is there, they are trying to address in that way. And a similar language that I showed was only for the brightness temperature, and then channel which channel was rather having this what you call finding out the fault on the model or something like that, that I have shown you. Channel means either wavelength or wave number. That also periodically I am saying interchangeably we are using both are same. Now the difference between the NSERF model and the ECMWF model, this is NSERF minus ECMWF on moisture profile at 500 millibar level. That is an integrated water vapor. So this is showing about a systematic bias. It's always positive. So the color code, everything is shown. It is about 21% systematic bias. NSERF integrated water is always on the higher side than what ECMWF is showing. As a forecaster, as a what you call duty meteorologist and then operational meteorologist, we are depending on so many numerical models. The objective analysis provided by these numerical models. So thereby, if we commit a mistake by understanding it, maybe the moisture profile is on the lower side or higher side. Definitely, our forecast will be to that extent it will be out. So that's one of the reasons probably this exercise done, and then probably there is improvement taking this in either of the cases. After all, in scientific community, we have to admit if at all any mistakes there, we have to readily admit, and then we have to do some correction. So this is one way input tool for the modelers, what they are supposed to look into, because after all the channel remains the same, and then the validation also something like that it's periodically going on globally by all means the people. Now, for the climate model, way back in 2005 January, the world community was totally alarming because there was a decrease in ozone, especially over the northern pole area, Arctic area. So this has been encircled here. And why this one? Probably this set of difference. So why it has, because January in comparison to January, this we are comparing for the same month. In comparison to January 2004, January 2005, there is a depletion, whether it is real or not, or otherwise, whatever the model projection or something like that is doing, basically that is committing mistake. Either the sensor is at fault or the model is at fault. That was entered into way back in 2013, based on the same spectral characteristics as a vertical built-in text equipment type of thing. Probably the characteristics are being analyzed every now and then with that coming to a conclusion like this. So on value as from the spectral characteristics, whatever has been put out, you can very well see that between 2004 and 2006, it was performing almost in the same line as that of what you call the zeroth line. The bias is not that high, and then it is almost the same for this one. Whereas between 2004 and 2005, where in 2005 alone, that ozone hole we are talking about. So there is a vertical gap. So this gap is arisen due to what? So probably the channel characteristics or the spectral characteristic was really working well, and then really there was what you call a depletion. So that was established as such. Okay, because the same depletion was not seen in 2006. So the channels are working all right, the radiometers are working all right. That particular year it was depleted, but again, whatever value we are seeing in 2006, we have to believe. So that is the order. What is the wave number which was used is maybe that 1040 is the peak wave number, that is 1040 per centimeter. That particular wave number was giving a concern for this one. So this has been established, and then probably whatever the ozone depletion at that time, it has been re-established that yes, the value was right. Then probably the satellite nowadays, we are talking about the global warming issue. Again, it's a debatable point whether warming is taking place, or thing is taking place, whether it's a mild or two or something that international community throughout we are putting it, and then there are some separate panels also available. Unless otherwise, we have authentic proof on some data, it is very difficult to establish. So with this particular introduction, the global warming issue, I am not going into detail because we are not going to convert the satellite meteorology introduction classroom as what you call global warming classroom or something like that. So the data as such, for which, based on which whether warming or cooling takes place, that should be first authentic. In the earlier arena, even now also, probably there are so much vertical area in the globe which are unrepresented in regard to the surface-based observation, and then probably we are not having quite a good amount of ground truth value with the full quality checked and then validated observations taking place. Whereas in the case of satellite, maybe a unique observation, a unique satellite is observing all the places, and then with that probably there should not be any bias over a particular location or something like that, unless otherwise the channel characteristics are properly established. That is what we have evaluated ourselves from 1960 to 2005. We have a comfortable stage. So data contiguity or initial problem work out what we call a long-term mean, based on which the current day, whether it is warm or not, positive anomaly, negative anomaly is going on. So the contiguity space and time in regard to original manual type of observation or instrument observation which are sporadic. So through that, whatever mean we were getting it is not sufficient enough. So satellite is one source. Maybe it is constantly looking all the political boundary without any bias or something like that. It is systematically looking on, and moreover, it is having a too frequent periodicity observation. So that is also another one, and then it meets the model requirement. With this small introduction, probably I will just say you how that alarming has taken place, because the entire world country, all the modelers. So now I am giving empty number of models. They projected a global warming as if it was going to 2 degree rise, so where 4.8 degree rise. Nowadays the ICC report is also going on, so it is open for everyone. And then this set of model output everyone has seen. Now the different models over the different packets of world, how it has come, probably you are able to see that one is with the natural forcing, another one is the natural and the anthropogenic forcing. So the blue color is only with the natural forcing, and then the pink color is with anthropogenic forcing, whereas the black line is over the observation data point. everywhere there is always a rising trend that the global warming is taking place, and then beyond doubt or something like that. This is one slide. Those who advocate that global warming is true, they will be presenting this set of slide. The land temperature as published, I am giving all the references also. UKMO, that is website information. This is on 2017 January 18, and the previous slides also probably you can very well take from their own site. UKMO is a well-recognized authority. Probably we have to depend on whatever they are saying on. So here you can see that the land, it is a land temperature anomaly. Just for your information, I want just to show you here. Maybe somewhere 1997 to 2005 or something that is varying somewhere between 0.52 to 0.42, which data I am going to present in the next few slides as well. So here itself probably it is just going on operating, and then probably sometimes it is decreasing, sometimes it's increasing, and then the warming or cooling we were unable to establish as told by other people. But generally the curve is what rising. That is the cause for the entire world community to say that it is alarming. It is for the global average anomaly, that is earlier one for only land, and then this is for the land and sea put together, and then this also having the similar tendency as such. And then what are all the agencies they are given, that has been given in the legend with the different shades of color. And this is only for the sea surface temperature. And then as we remember, probably we have that sea surface temperature available authentically only after 1960 when the satellite era began, like what I said in yesterday's classroom. So it started only with the 1960, the satellite era began, and then prior to that, whatever observation on vast expansion of ocean, that was only on either voluntary cooperating mechanism, buoy observations, ship observations, or buoy observations. So these buoys and ship observations, probably whether it has been standardized, calibrated, and then that was a big question. And then the data is also somewhat what you call reliable or unreliable, that debate going on. This is the NOAA published database of what you call land and ocean temperature put together, and it is having a lengthy record from 1880 up to 2016. When I got the data, I plotted it over, and then I just saw that beyond maybe after 1976 or 77, there is completely a warm anomaly which is taking place. So that shows that it is a warming signature as such. So that's what I am saying. All these advocating that yes, there is a global warming taking place. Beyond 1977, 1976, probably the next slide I have written. It's 1977. I already written here. Up to 1976, but for the small portion wherein that warm cooling were there, otherwise it was perfect cooling. So initial periods are up to perfectly cooling. It's starting from 1880, remember. And from 96th point, which is nothing but 1976, up to that vertical cooling phase is there, in between a sporadic warming. Whereas from 1977, complete warming episode is taking place. And the computation based on the previous slide, the total change in the mean anomaly is somewhat very, very insignificant, in the sense that 0.049, because the initial was completely a cold anomaly for about 96 years, and beyond that 1976 alone, the warm anomaly is taking. That is why that negative and positive are masking each other, and ultimately mean anomaly is very, very insignificant. Minimum is minus 0.4, maximum is 0.94. Okay, and from 1880 to 1976, that we already discussed, it is almost a negative anomaly, which is saying that the global cooling was taking place at the time, and it was ranging from minus 0.12 to plus 0.29, because in between there was an aberration, and then probably it was the very coldest was minus 0.4, on par with that of whatever I have given here. From 77 to 2016, it is completely warm, and then there was not even a single year with cold episode or something like that. So it is also projected. Now the question is, all these solutions are probably, even the observation with instrumentation, what we have, the uncertainty or resolution or standards or something like that, it's always plus minus 1 degree Celsius. From the same data point, if you see 1998, it was warm with 0.52 degrees Celsius on anomaly. In between there, it was going up and down. 2006, it was 0.42. In between, there was so much amount of thing because of the lack of space in the slide. I am not projecting all. Our uncertainty error is plus minus 0.1. By meandering with doing some arithmetical jugglery, 0.1 add here, subtract here, minus 1 here, or minus 1 here you can add and then subtract with the 0.1 here, something like that. Ultimately, we are having a clear-cut way of understanding it because the uncertainty itself is more the mean anomaly, whatever we have output. It's 0.1 degree in the observation error. Okay, that is what I am calling as uncertainty. So our ex-Director General of Meteorology in India Meteorology Department, he made a very fantastic statement that this I have been referring everywhere because I like this statement. When scientists talk about the small quantities with a large uncertainties, we must say our own freedom from our opinion. Since 1998, the Earth could have been either cooled by 0.3 or warmed by 0.1, depending on how we look at the Earth by meandering or making a jugglery on adding a 0.1 here, subtracting here, or subtracting here, adding here, something like that, you will get the same figure. Probably, it's purely an arithmetic interest. So this is what we call a very, very small quantity we are worrying about because it's a globally average scale. That is why even the 0.1 degrees matter a lot. Otherwise, if it's a single place, we don't bother much. Now, so far I've been discussing about the global warming, which is true, something like that. Only one slide I am keeping it open for it's a myth. Why I am coming, probably I will come to it. This is not necessary for our classroom lecture. Even then, how the satellite is going to address the problem. That is my idea. That's why I am keeping this set of slides. So NASA ex-chief Michael Griffin, he was saying his own statements have been copy-pasted from whatever was available in the internet those days. So he himself was saying that probably this set of small quantity, let us not relate whether it is a warm. But based on the data, probably the trend is very much there. That's what the NOAA data on which I have prepared the graph up to 1926, cold or negative or global cooling was there. Beyond 1977, the warming was there. So that's what he meaning. Beyond 1977, there is a warming, but no ground warming has occurred since 1988, despite the increase of CO2. That is his statement. That is why I like this statement very nice. So this is the period in which everywhere throughout the world community, scientists were talking about the CO2 is increasing, this, that, all, and then with the CO2 increase, definitely there is a chain of cascading effect, and then probably there could have been much more warming we should have anticipated. But unfortunately, that has not been established. That is what his statement says. And probably the solution is what the last bullet. When we get a sufficient data with the complete oceanic area, right from tropics to extratropic, and then make a huge study on this one. Once the database is right now also from 88 or 87 onwards, completely the SST etc. has been quality checked, and then there is mapping going on. Then the moment we get some 30 years of data, then we will be in a position to say that authentically whether the warming is taking place or cooling is taking place, and then which packet. So this is the final pilot project which has been done by NOAA group, especially on the SST. The database is from 1988 to 2005. The global average SST has been plotted over here. And this set of vertical map, this is for about how many years? It is about 17 years. So another 13 years plot, once it is there, the climatology by mean the 30 years, whatever we are saying, it is likely to be there. Then we will be in a position to establish and the recent day quality check time. Only thing, our observation, whether it is a ground or ground manual observation or instrument observation, so it should be comparable with the quality standard, and then quality check has to be there, and the calibration, whatever be the error or something like that, that we have to really take into. Then alone we will be in a position to get meaningful data. Otherwise, everything will go as what you call rubbish and garbage. So coming to the satellite application, especially on the climate monitoring, it is a global Earth radiation budget experiment which has been coined by our WMO, and then so many things, contributors by the satellite service providers. So they come a long way in understand. This is classic picture of a global radiation, which I showed in my first lecture about the tropic is getting extra energy, and then it is getting redistributed poleward, and then which we used to call as general circulation there by the heat balance, the energy balance is maintained, and then so this is in a view graph. by Wallace and Habs book, and then earlier book with the black and white in 1987 or so, that is very much available with the updated version. So you are able to see that in the tropics, the value of OILR is very much high. As we know, the sun is meandering between Tropic of Cancer and Capricorn, and then thereby the incoming solar radiation is very high, and then that particular solar radiation maybe over the tropical region, expanding over the higher latitude and the poleward side. The poleward side, it's hardly about 100 watts. Either is 6 months continuous dark, 6 months continuous sunlight. Even then, because the high albedo of ice, etc., it is not receiving the way in which the tropic is receiving the energy from solar. So this way, the polar side is hardly 100 watt per meter square, whereas the mean tropic is about 300 watt per meter square. That has been captured here. In regard to the long wave or the terrestrial radiation, it again depends on the contribution by the clouds, the cloud tops, and then precipitating clouds, all these phenomena. So that's why, the value over the tropic, even whatever you are saying, the pure red color, so it is not that red. The reason being where the perpetual forest and then rainforest is there, so the outgoing long wave radiation is very high, very low, and that is correspond to the values what has been displayed over here. So this is about the first budget experiment as such, we are for our understanding as it is. Now, and then this data is from NASA on air radiation experiment satellite data. So here you will see that maybe right over here I will be taking our Indian region. So the Indian region, the yellow color is there, which is somewhere corresponding to between 10 and 30, 40, 50, that value. So it is surplus again. Even though the clouds are there, clouds are not available all the 365 days, and then this is only the average mean. But there are some area wherein you can see the negative anomaly or negative value is there, not negative anomaly, negative value. There is incoming minus outgoing. Okay, this outgoing means again a cloud of radiation whenever there is a cloud. So here over the Saharan desert and then I think there are very large value of negative value coming to some 60 to 80, etc. So this is actually, whatever even incoming radiation is there, they are released beyond whatever they receive. And in addition, whatever other general circulation pattern gives it. So the deserts are always emitting more terrestrial radiation than what it receives. Okay, that is the idea. So that has been captured well here with the data source. So this is the contribution from NOAA, NASA, and then all the service providers other than our Indian launcher. Now, from Indian side also we have started our beginning. So we are making what you call a data plot of monthly average of OLR and then weekly average of OLR, daily average, and then instantaneous. Everything nowadays in the website of IMD, these pictures are available straight away. So the last month, July 2019, is on the left side, and then just 4 days back before the classroom started, that particular thing, the week average of 12th to 18th of August 2019. So here you can see that Indian region is there, and then that color corresponds to what you call the value somewhere between 190 and 210. That itself suggests these are all the months rain bearing cloud and the OLR is irrigation. Whether the OIR gives cloud or gives the OLR the same, because one is the cause, another one is the effect as it is. The high rising cloud, definitely it will be giving a lower OLR as we know, because it's a cloud of radiation as such. How the OLR has been used for the southwest monsoon studies, I am going to concentrate in another some 7 or 8 slides like this. OLR can be considered as a proxy for our convective activity. So with that only, probably the OLR value has to be converted in terms of either temperature value, 235 km, K, etc. So that was used for precipitation process, and then OLR as it is 200 watt per meter square, that is used for our monsoon studies, etc. With all the data available from the satellite, we are in a position to better understand the monsoon, and we are able to explain what went wrong or what is likely to happen based on the OLR studies. That's what we are going to see in the next 7 or 8 slides. The OLR as such, to understand what onset of monsoon over Kerala, the southwest monsoon over Kerala, that was studied well by Wang et al., which was published in Journal of Climate in 2009. So here what they did, the YLR of what are available, I think it was about 28 years data, if I am right, 29 years, yeah, it's mentioned here, 29 years. So those data that are analyzed in depth, every year onset date is not rock steady, it will meandering. So each year onset date, etc. Prior to that, about 4 pentards. 1 pentard is 5 days, right? So 4 pentards prior to the onset, and then 3 pentards after the onset. That was systematically studied. So prior to the onset, it was always causing somewhat a dry atmosphere, and then the dry atmosphere in the next 2 pentards, dry atmosphere of Kerala first, okay, Aravan Peninsula India. Then next 2 pentards, that is the first 20 days, it was only over the southern peninsula India, dryness was prevailing. Another 10 days later on, so the dryness was continued up to it covered throughout India, and then there be a heat wave type of thing was produced. So that was first established by seeing the YLR data. So here they average the YLR for a long period, right from March up to the onset date. So that has been plotted over here. You can very well see that prior to the onset, the YLR was always on the higher side. That we know pretty well. When there was no cloud, YLR will be naturally high. So the YLR starts decreasing in the moment the clouds are coming in. Maybe the time advances, it is coming to. At the time of onset over Kerala, it is just coming and touching somewhere the value close to 200 watt per meter square. So this is the first view graph which was published in the Wang et al. Paper, and then thereafter this has been used as a monsoon criteria by India Meteorological Department. When the YLR value over a box of 5 degree north to 10 degree north and 70 degree east to 75 degree east, if it touches that 200 watt per meter square, it can be considered as another criteria for declaring the onset of southwest monsoon over Kerala. So the second view graph from this one, this is the mean based on that we saw, and then this is the days of onset from that particular day. 0th day is the onset day. 5 days prior, what was the YLR value? 10 days prior, what was the YLR value? They have gone up to 50 days prior to onset of day. What was the value? Down maybe some amount of what we call convective phenomena might have taken our value from low, or there could have been an Arabian Sea cyclonic storm, this sort of thing, and then the 29 years period average alone it is showing. What we are supposed to know here that on 0th day, that is the onset day, it is touching somewhere 200 watt per meter square. So that was the idea, and then that is used as one of the criteria for declaring onset over Kerala by IMD. And based on this, the IMD started its own way of what we call accumulating the database and then put into proper use. The 5 years data is been plotted in different shades. You can see it is 2014 to 2018 over a box area, whatever was defined earlier. 2014 to 2018, how the YLR has been on different onset dates, different dates for each year, and then how the onset of the clip. So this is a practical utility for the operational forecast. Now, explaining the delayed onset in some years, probably I just put one slide which is very useful according to my concept and understanding. Way back in 1983, the onset was much delayed. It was delayed by 13 days. It was onset over Kerala on 13th June. You can very well see that the YLR anomaly is positive. What it suggests. So naturally, the clouding has not reached, and then that is one of the reasons probably that anomaly we are plotting as it is. At the same time, the sea surface temperature was cool. The sea surface temperature anomaly was negative. So sea surface was cool. So this also explains why you probably know that delayed onset was taking place. So this also published a paper from that I copy pasted. Now, the entire world community way back in 1997, because of the strongest El Nino at that period, it was apprehended by the entire world community that Indian monsoon is going to very, very scanty, and then India is going to face severe drought here. So almost all the numerical model was suggesting like that, but some of the long-range forecast of IMD, they were maintaining that it will be normal, it will be normal. So even our ex-DG came to the press, and then he allayed the fears of other thing, it will be normal, because El Nino alone was not the criteria. and there could have been other parameters which will be contributing for a normal monsoon. And he was right in that way. So this is the classic example which was studied in a different way, a concept called EQUINO, the Equatorial Indian Ocean Oscillation by Gadgil et al. So July 1907, we were supposed to have a scanty monsoon, but unfortunately or fortunately for us, it was a normal monsoon. And 2002 was totally drought and scanty. They didn't have rainfall. So these two are the contrasting phase. Why I am saying contrasting phase? Because the model prediction based on El Nino Southern Oscillation ENSO, so was also saying that both the years it will be drought and then both the year it will be deficient and scanty. But a reanalysis done by Gadgil et al. That showed something fantastic, a different concept using the YLR data. So here, what she said, their group, they were saying that this what we call equatorial Pacific, you can you make one box over here and another box over here. So that latitude longitude, I am putting it over here. The Eastern Equatorial Indian Ocean, which we are calling as Eastern Equatorial Indian Ocean, EEIO, that is going by 10 degrees and then equated to 10 degrees south. So here the suppressed convection, where it exactly it is this one. Okay. So here also the color also it can very well see the increased YLR. Increased YLR means suppressed convection, and enhanced convection over the other part, that is 10 degrees south to 10 degree north and 50 degree to 70 degree east. So this area. So whenever this set of thing is there, normal monsoon is there. This is 97. Okay. So on that 97 YLR was already it was raining. That is why YLR is there. That also we can very well say because it's the cause and effect story. Okay. Even then, you can very well see that these and days they are getting oscillated in different periods. Maybe that suggests that whether the clouding is coming and then monsoon is performing in a normal way or a scanty or a better way. So by comparison, you can compare 2002. So this positive value of YLR anomaly is not seen over here. Instead, it is negative. So that shows that here it is an enhanced convection. Negative YLR anomaly, that is the low value of YLR. So cloudings are there. That is why here it is precipitating much, whereas here it is almost dry. And the model performance as such, this what you call the oscillation type of this one. It is what initially they were calling as Indian Ocean dipole. So it's almost like a dipole type of mechanism. When convection is taking place on the eastern side and then western side is a suppressed convection, that is not favorable for the Indian monsoon. That is the idea. That has been very clearly brought out by the view of 1997 and 2007 by comparing those regions of what we call the oscillatory mechanism, Indian Ocean dipole and then equatorial Indian Ocean oscillation. The positive phase is associated with the inland convection over the western side. Western side is our Indian region side, Arabian Sea side. So that is favorable for an Indian monsoon that has been re-established. Here the advantage was that when the entire community was saying about 1997 severe drought and then completely when our ex-DG Dr. Kelkar came on the press and then he was saying that it's normal, something like that. Ultimately, it was a normal monsoon year. This was not captured by the earlier vertical dependency on El Nino Southern Oscillation, which was suggesting that it is going to be a totally scanty monsoon, but unfortunately it was not scanty, it was normal. The same way, 1994 and 2002, so one was an excess rainfall, another one was a scanty rainfall. Both have been well captured by the EQUINO symbol. So this is also probably, it gives an idea that how the satellite data will be helpful in climate studies and then climate modeling, climate understanding. Could probably in the near future, all the future models will be in a position to better predict the monsoon behavior, monsoon onset, monsoon performance, etc. years to come. So it was about what you call the southwest monsoon, which was going on the line of thing because it's a line light of throughout the world community. But a smaller area, miniature area of monsoon, which affects only the southern peninsular India pocket, that also only the eastern coast, like full Tamil Nadu and then neighborhood, some portion of Andhra Pradesh and then some portion of the interior, south interior Karnataka and Kerala, that is affected by the northeast monsoon. So here also the same OLR based study was carried out by Raj et al. Group. And then here they found out a fantastic result, which is rather contrasting with that of what you call southwest monsoon. Southwest monsoon, when the monsoon advances from south to north, the cloud band also will move from southern hemisphere to northern hemisphere or equator to the northern part, because the wind is also prevailing the same direction, southwest to northeast. Whereas in the case of northeast monsoon, the wind is coming from northeast to southwest, whereas the cloud moves from south to north. So that has been well captured by, this is an observation fact, and then that has been well captured by our instrumentation, that is our YLR values. So here you can very well see that from monsoon onset day -4 days, prior to onset 4 days, prior to monsoon onset day, where was YR, and that YLR threshold value was 10 as 200 water per meter square, which has been shaded over here, similar to what southwest monsoon we were doing it. So -2 days it has advanced further, on 0th day it has come, and then +2 days it has come out. So the clouding is probably now from southern side it is moving up, and then it is coming, and then sorry for the interruption. From the broadband, I have come to switch it over to mobile. There was a break in communication. So from the study based on the OLR, southwest monsoon and northeast monsoon, we are seeing, and from there we are switching over to satellites used for climate monitoring. The global climate observing system has identified umpteen number of variables to be monitored over atmosphere, ocean, and land area, and they are called as the essential climate variable (ECV). So that has been documented in the literature as such, and then all the satellite service providers, they have been asked to have complete monitoring and then observation on these parameters with a defined accuracy limit and other things. And we know pretty well this set of vertical monitoring and observation by space-based, which is an independent, and then probably now same instrument is viewing different topography and different vertical boundary alike. So this has the advantage, and then in addition, it is having an observation on local scale, mesoscale or regional scale, and then global scale or planetary scale. All these are multispectral advanced, and then moreover, the observation is always possible on day and night. So these are all the advantages of space-based this one, and then we are constructing a time series over this one, and we can very well revisit any parameter if it has gone bad, so that will be in a position to get maybe a future database. Coming to our atmospheric variable, these are all the variables defined by the GCAS, surface wind direction and speed. Yesterday and day before yesterday, we discussed about the scatterometer wind over the oceanic area, whereas over the land area, probably still we are having a layer average, the atmospheric motion vector, water vapor wind vector techniques, and cross correlation technique, whatever we discussed. Through that, we are having a layer based average of wind over the land surface, and upper air temperature, water vapor, etc. through the spectral characteristics and sounders, we are having it. Cloud properties, we already seen that AOD, how it is made, or something like that in other different parameters. Precipitation estimation based on the brightness temperature as well as from the YLR, one can make it. Earth radiation budget, we just now we saw how it is useful. Probably different packets, how the YLR incoming as well as outgoing, and then the deficit or surplus that can be found out. ozone hole and then ozone depletion or ozone concentration that can be made, aerosols, and then all the trace gases, atmospheric wind, upper wind, etc. So these are all from the atmospheric side. Ocean side, there are everyone which cause a lot of what you call image interpretation problem, especially on the albedo point of view, because the ice, etc., they are having a higher albedo, and then this also has to be monitored, especially when the climate model is using the ice coverage and then ice accumulation, especially for the long range forecast type of thing. So these are all probably in the GCAS variable that has been defined. Now the trace gas monitoring, there are so many satellites launched, and then right now also METAP is doing the business, it's ongoing, and then future satellites all have trace gas monitoring. Right now also the geostationary Earth orbiting satellite GEO as well as low Earth orbit satellite, the LEO satellites, they are on the last two or last three in fact. So they are still in vogue. Based on satellite data, the International Satellite Cloud Classification Project was coined by WMO under the Climate Research Program of WMO. And this initially, it was thought of for about 15 years period they will collect the data. Now it is ongoing. Up to 2010 data has been collected, and then with that, cloud classification has been made. So this view graph suggests that what are the phase of the cloud, and then how it can be put, and then how we can identify, etc. Especially for the what you call different regions, what are the favorable cloud climatology for the region. Then the other one is the Global Precipitation Climatology Project. So here the precipitation project was started with the coarse resolution. Now also it is the same way. Every 2.5 by 2.5 degree grid, that is 250 kilometer by 250 kilometer approximately. The precipitation on a monthly scale has to be plotted and then displayed, and then it is useful for some analysis purpose, understanding purpose, etc. So under this project, there are different contributors from the satellite service providers. The IR sensor contribution by GMS Japan, Meteosat, Europe, and then USA satellites of GOES and NOAA. Microwave sensors from the NASA and then microwave sensors from the NOAA, they are in use for this particular project. The same way that has been listed. One great advantage is that they are having a calibration validation, CalVal, also as a component that has been put, and then that is the responsibility of University of Oklahoma. Probably ultimate responsibility, and then making a coordination, etc. That was with NASA. So with this project, the first outcome was published by Alder et al. In 2003, and then he himself modified with additional data in 2005. So this is the 2005 figure as such. Maybe the globally, how the precipitation rate has been put over here, and then it is the way in which probably you can very well see over the equatorial region, the precipitation rate is somewhat higher. You can see the legendary scale. The yellow color corresponds to somewhere between 5 and 8 mm per day. Okay, so this is the way in which probably based on the data it has been worked out. It's an ongoing project, and then the satellites are contributing probably in a big way. It has to come, and then it will say. The ever latest picture I downloaded that this was yesterday night, and then this is you can very well see that for the month of July it is readily available in the site, and then site address is given over here. The precipitation anomaly. You can very well see that the Indian region. Maybe you can very well see it is very difficult. Maybe. So this is the Indian region. You are saying that the value because of the monsoon we are getting a higher vertical precipitation anomaly. So this is on the positive side. So negative side is nothing but the negative anomaly. Precipitation is weakening in comparison to the normal of this particular month. And the long-term mean is the LTM. Long-term mean is 30 years data. Okay. So this is how the GPCP project is helping us. How the climate is behaving that way. Precipitation and vegetation monitoring. So precipitation estimation based on the YLR, and then based on the brightness temperature, we can say we can estimate. And then there were two satellite projects, TRMM, and then the further enhancement, GPM constellation of satellites, global precipitation mission satellite, of which India also has contributed to megatropic satellite. So this is the TRMM satellite based average, whatever has been published when it was in orbit at the time. Now the Indian contribution as of now, the current one. So our July month precipitation total month average that has been put over. Probably we also will contribute for the data bank, and then maybe for understanding the GPCP project as well, the nice go understanding the climate over different region, and then especially the precipitation nowadays it's a must, especially the first water. Otherwise, people are starving for water, etc. That sort of thing. This is the tool. Now, for after the precipitation, definitely we have to think something of food. Though I have not covered this particular NDVI in any of the 4 slides, I thought, in the climate I will squeeze in yesterday. I told you also when I was speaking. So the vegetation index, as a vertical, I am taking as a considering as a climatic parameter, because over a particular season alone, the crop will be brought up, and then so that way probably as a climatic parameter I am considering this one. But this is the plot of reflectance over wavelength. Ordinate is reflectance in percentage. Abscissa is wavelength in micrometer. You can very well see that there is a peak, say from a low value, suddenly it is getting peaked. So that has been listed over here. Any value up to 0.5 to 0.7 micron, it is having a lower value of reflectance. And probably once it is coming beyond the 0.7, even going up to 1.3, so it is having a very high value of 48% of vertical. This is the 48%. I mean, this is 50, this is 48. So 48% at 1.3 micron radiance, etc. So that way, probably we can very well compare how the vertical, the green leaves will reflect, and how the desert will reflect. So that way, probably it is giving an idea about the vegetation growth. And moreover, this will be useful for the administrators and planners, whether the crop is withering or it is in the blossoming stage or it is in the proper growth as per the crop weather calendar or something like that. So that way, probably one particular use of this particular product, NDVI, based on the compare and contrast of reflectance received from 2 different channels, that will be of much use. So NDVI as such, it is defined, initially it was from the Polar Orbiter Satellite NOAA series, VHRR series only. Channel 1, it is on the band 0.58 to 0.68 micron. You can very well center somewhere also. Nowadays, in other sensors are point now, it is not on the range. Okay, so this is the range normally. And channel 2 is the near IR as it is. And the reflectance received from the channel 2 minus the reflectance from the channel 1, then a summation of this one, it is divided by the summation, that is the normalized difference vegetation index, NDVI we call. So the implication is that, as we know, because the greens and this one, they reflect much more on the channel 2, that is why it is always having a positive value, maybe ranging from 0.1 to 0.6. So any positive value, it suggests that it is vegetation in the normal shape and the growing state. Whereas the cloud and water, they have the vertical reflectivity higher on the visible side than the IR side. That is why the minus contribution will be there in the numerator, and then NDVI will be negative totally. The barren soil as well as the rocks, etc., they have the similar reflectance on either of the wavelength. So the subtraction will be almost close to 0. So this is the way interpretation. Interpretation is very easy in this particular case. Positive value of NDVI is growth of vegetation. Negative value is either cloud or water or snow, etc. And barren land is very close to 0. But it has its own limitation, as any other product will be having its own limitation. We have to come out to address this way. One is that the cloud contamination, and then cloud will be having what you call some problem in getting the exact value determined. So we have to have some cloud-free day and then cloud-free area, etc. So unless otherwise we know beforehand whether the particular area is having the cloud, etc. So we will be having a misleading statement and calculation way. Another one is that the satellite viewing angle and then solar angle, because it was originally thought over from polar orbiting satellites, the look angle will be different for each pass. We have discussed enough on it. So these two are considered as the limitation. Both the limitations have been ruled out now, because we have the IR channel or the atmospheric window channel available. So with that we can compare and contrast. The cloud area can be eliminated. Only those areas which are cloud free, that alone can be used for computing this one. That is the first one. The second one is by taking what you call the value from the geostationary satellite, etc. Maybe the look angle problem can be solved, because the satellite is always having a similar look angle. So that is why now we are in a position to have the vegetation index estimated even for the geostationary platform. So that is the global vegetation index as such. a typical example on a view graph. The formula is channel 2 brightness or reflectance minus channel 1 brightness divided by channel 2 plus channel 1, and it is multiplied by what you call a constant of proportionality by the regression equation, and added up with the what you call limitations, and then this way. The next one as an improved version is called as the ratio vegetation index. This also has been coined. Both are having its own application. This has been used by different group, maybe internationally. Even in India also, there are some local packets, they were using it. And then with that, we'll be in a position to say, suppose there is what you call water problem for irrigation purpose, water is not there. Because of that, a peasant is suffering, and then his plant not growing to the proper shape, etc. So that will be a problem for insurance people, etc. Whether it was really having the good growth or withering stage or something like that. So that way also probably it is useful. In addition, probably the water necessity can be addressed. The moment we say that the particular plant is suffering from drought, there are alternate solutions like drip irrigation, something like that. That has been coined. So through that way, probably after all, the agricultural industry can judiciously utilize this product to have the better or economic benefit as such. And after all, food is a must for every human being, and then this is the way probably how the satellite will come on help to this one, monitoring the vegetation growth and then vegetation need, stress, etc. How it can be addressed to. The moment we say stress, probably some amount of what you call artificial irrigation, drip irrigation, that sort of thing we can very well put it. So this is the way in which from the INSAT picture we are getting the plot, and then so here also there is a drought monitoring group. They will be using this one, and then they are giving advice based on this one. So far we have discussed on the last 5 modules. Today is the 5th module. First one we saw the basic concepts of remote sensing, and the second one is the polar orbiting satellite with what you call how it was evolving over a period of 60 years from 1960 to the current day. A geostationary satellite from 70s and then the current day. Then the second model we saw, and then we discuss about the data products and then image interpretation technique as such in the third module. Yesterday we discussed about how the satellite data can be useful in weather monitoring and then weather application, especially the model performance can be improved by injecting the satellite derived oil or brightness temperature, etc. Maybe it's an ongoing research, and then